In this video, I'd like to think a little bit about net torque and net force. And part of my doing this is to try to highlight some of the things you want to think about and be aware of as you start to choose how to set up problems, because particularly with torque, your choice of origin often matters and either makes your life easier or makes your life more difficult. So being conscious of what some of the issues are is pretty helpful. To get to that, I first want to ask the question, though, when we talk about net torque and net force, what do we actually mean? Well, we mean that when you've got some system, right, you draw some system boundary, and we've talked about the idea that force is the flow of momentum. And similarly, torque is the flow of angular momentum. And so in the same way that wherever you apply the force to the system, it still causes the net momentum of the system to change. By the same token, wherever you apply the torque to the system, it still causes angular momentum to change. And so any torques applied to the system yield a change in angular momentum. Any forces applied to the system yield a change in the linear momentum. So it really makes sense to talk about the sum of all the forces on the system. This is the net force on the system. And the sum of all the torques on the system is the net torque. Okay. So to get at that, let's ask a couple of questions. Is it possible ever to have a net force without a net torque? Well, the answer to that pretty clearly is yes. We've talked about an example of that already. So here was the example. Just to remind you, I've got a wrench, right? Here is my bolt. If I'm calculating the torque about that point and I apply a force here, pretty clearly that force does not give me any torque because R cross F gives me 0, right? The position that the force is applied, that position vector is parallel, or in this case anti-parallel with the force vector. So this gives me net torque of 0, but net force is non-zero. Okay? By the same token, I can certainly imagine situations where I'm actually applying a net torque to a system, but not applying any net force to the system. So let me give one example of that. Let's imagine I've got a pencil. This is a pencil, really. That's on the table. And I take my fingers and I apply a force here, and I apply a force here. And I make those forces equal and opposite, right? Well, certainly if I choose the center of the pencil to be my origin, this top force, right, I've got a position vector for the top force that's like plus L over 2 in the j hat direction, right? The position vector for the bottom force is minus L over 2 in the j hat direction. This force on the bottom is plus F in the I hat direction. This force on the top is minus F in the I hat direction. And when I take the cross product of R1 cross minus F in the I hat direction, I get an answer of plus L over 2 times F times K hat. And by the same token, when I take the cross product of L over 2 in the J hat direction with a negative sign times F in the I hat direction, I get plus L over 2 times K hat times F. So the net torque in this system is going to be L onto J hat cross minus F I hat plus L onto J hat with a negative sign cross F I hat, or F times L in the K hat direction. Notice that this is tending to cause the pencil to rotate counterclockwise. Counterclockwise corresponds to rotation in the positive K hat direction, so my torque is in the positive K hat direction. So in this case, my net force is 0, which is to say that the center of mass of this object will not accelerate, but my net torque is non-zero. And so we have this idea that it's possible to have net torque without net force, and also net force without net torque.